Started a little late on the recording. So the idea being, this would be like an event. I have the set of all things in the universal set such that they match my specific outcome. So a simple way of thinking about this, for those who've had statistics, simple probability. I'm going to flip a coin 3 times. Okay, what are my possible outcomes? Well, it'll be head, 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 tail, head, tail, head, head, tail, tail, and so on. There'd be 8 outcomes of strings of H's and T's. I am interested in all of the outcomes that have exactly 2 tails. So this would be the 8 outcomes, head, 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 tail, 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 and so on. I want all of the things in these outcomes such that I had exactly 2 tails. So the P of X would be the specific outcomes I'm interested in. So this is always the universal set. P of X would always be something smaller, okay? But this is how set builder notation is basically used, okay? Now, this is the most generic way of saying it. Now, this is just a tool. This is not the end all. Now, from a notation standpoint, I want to introduce a couple of symbols. The first one is that little guy right there, which is called the element symbol. And we're all very familiar with that. The thing is, be careful, it is not this. That's an epsilon. That's something totally different. Never use an epsilon when you mean element. The element symbol means if I have a set of things, an element is one of the things in the set. So for example, here's my set S. My set S is, let's say, 1, 2, 3, 4. Okay? The number 1 is an element of S. That would be a true statement. Would it be a correct statement to say the set 1 is an element of S? I'm asking that question. Well, I don't have a set bracket around 1. The set of 1 is not an element of S. Now, this is where it gets kind of confusing, but wait a minute, 1 lives in here, yes, but 1, I'm treating this as an entire set. So there's a different symbol, and it looks like this. It's either this or it's this. Not all textbooks agree, and it's really not that important. This is called the containment. Okay. And you use this whenever you're trying to say something is a subset. Okay, a lot of people think of it kind of like a less than versus less than or equal. I don't really care. It's not really a thing. If I say something is contained in something else, now we can go back to the statement here. The set that includes only the number 1 is contained in the set S. The individual element 1, individual element 2, but now I'm saying a set. So I could also say the set that has 1 and 4 is contained in S. So sets are contained in sets. Elements are individual things from the set. Now, it might seem like we're splitting hairs. No, it really isn't. It's really important that we make the distinction between the two. A set is an entire thing. Now, how many different subsets could we have? Well, we're going to study that a little bit later, but it turns out there's quite a few. In this example right here, there's actually 16 potential subsets that I could get. I'll give you a hint, 2 raised to the 4th power. There are 16 potential subsets. I could have the subset that only has 1, that only has 2, that only has 3, that only has 4. Then I can have all the subsets with 2 things. Then I can have all the subsets with 3 things. Then I can have, what about the entire set S? Is the entire set S contained in S? Yes. What about the set with nothing in it at all? That's called the empty set. Is that contained in it? Yes. So, oh my gosh, there's a whole lot of choices here. But if I said elements, there's exactly 4 different elements, and that's it. There's 4 different things that I could say this way. There's a lot of subsets. Now, I want to make sure that we all understand the next thing really clearly. if you've all had Calc 2 and you remember sequences and series. Some of you didn't love sequences and series, some of you did. Maybe it was awesome. But sequences and series, there's always some confusion because a lot of textbooks do a really, really poor job when it comes to sequences. And we're going to study sequences in here later, not the calculus approach, but understanding a sequence. If I said, consider the following sequence, 1, 2, 3, 4, dot, dot, dot. Well, first and foremost, dot, dot, dot means this is infinite. So this means it doesn't stop, but it also means if a clear pattern has been established, then you continue on in that pattern. So if I said, what is the next value? I think we'd all say, yeah, it's obviously 5. That's not really ambiguous. If I just said 1, dot, 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 well, nobody knows what the next thing is. I haven't established anything, so this would be very bad notation. Now, this is a sequence. Is this sequence the same as 4, 3, 2, 1, dot, dot, dot? Because I gave you the same 4 numbers. Is it the same sequence? Well, this is decreasing, and I think I'm going to start having some negative values soon. This is increasing and growing without bound. These are not the same, even though they have the same values. A sequence, and this is, by the way, calculus books really destroy this one. They just wreck this all over the place. A sequence order is implied. So if I rearrange the order of a sequence, it's a different sequence. If I said, consider the set 1, 2, 3, 4, consider the set 4, 3, 2, 1. Are these the same sets? And the answer is yes, because a set is a collection of things. It's a list of things, no order is implied whatsoever. For example, I have a roster of names of the students in this class. If I rearrange that roster, it doesn't mean you're no longer in the class or something happened. If I rearrange that roster, it's still the same group of people. It's kind of like having you all stand in my living room and I say, okay, now move around a bit, scatter yourselves. The same group of people. My roster is in alphabetical order out of convenience. See, I could have made it from oldest to youngest. I could have made it from tallest to shortest. It's still the same list of people. A set, no order is implied. A sequence, absolutely order is implied. And the problem in a calculus class, they often treat a set and a sequence exactly the same. And that's very contradictory. That's not true. And in fact, if you open up whatever calculus book you used, they probably defined a sequence using set notation, which is really, really bad. Right? That's not good. So this is a sequence, order matters. This is a set. We're going to study these later, but for now, 2 sets are equal if they have the same elements. So if I said how many elements are in the set, you'd say, well, 4. So if I said how many elements in the set, that's called the cardinality of the set. The cardinality of a set is how many elements are in the set. Now I'm gonna trick you a little bit. Okay. How many elements are in this set? 1. In a set, you never repeat elements. That would be the equivalent of I have a class roster and one of your names appeared 10 times. You know, there was an error, computer error. One of your names appeared 10 times. You still only get to count 1 time. Okay, there's not 10 of you. So when you're doing a set, you never repeat elements in a set. You don't. If you guys remember domain and range, baby algebra domain and range, this is the same idea. And I'm giving an example of something you can relate to. If I said I'm considering the following set 1, 2, 2, 4, 3, 4. Okay, let's keep it really simple. And if I said, what's the domain of this set? You would say the domain is, and a lot of times we list it this way to make it easier. It's 1, 2, and 3. If I said, what's the range of this set? You'd say 2 and 4. You don't say 2, 4, and 4. Because then if I said, well, can you give me a mapping from the domain to the range? And all of you probably have done this in an algebra course. Well, 1 got mapped to 2, 2 got mapped to 4, and 3 got mapped to 4. So that means the two elements got mapped to the same element. This is still a function, but it would no longer be one-to-one. This is one of the ways we'd identify something like that. But we don't list the 4 twice just because it came up 2 different times. Now, there are 3 ordered pairs here, clearly, but there's only 2 elements in the range, not 3. So when something gets repeated, that's redundant. You generally don't repeat things. So that's meant to just kind of trick you in a sense. So most of this stuff is pretty simple and self-explanatory. So the last thing I want to go over is something called a Cartesian product. Okay, a Cartesian product is a very specific way of creating sets. Now, you've been dealing with Cartesian products your whole life in algebra. You just didn't call them that. So those of you who have had linear algebra and you understand notation, the real number line, we call it R. But the XY plane, okay, we call R2. If I said, well, what about if I'm in 3 space, okay? Well, we call that R3, okay? And in linear algebra, we study Rn. We study n-dimensional spaces. And how do you know? Well, because in here, ordered pairs are generally in this form, but over here we'd have ordered triples, and the order is the key. If I rearrange the elements in an ordered pair or an ordered triple, it's a different location, a different address. But the point is how do I create R2 and R3? Well, I actually am doing a Cartesian product of the real numbers with the real numbers. Okay, so it actually, technically, this is equal to R, and we say cross. Not like cross product, because these aren't vectors. And in this case, we do the same thing, R cross R cross R. So how we actually go about showing this, keep it very, very simple, because there's nothing about a Cartesian product that should ever be challenging. So let's call set A, the letters A and B. Let's call set B the numbers 1, 2, and 3. Okay? A Cartesian product creates ordered pairs to start with. So if I said, what's the Cartesian product A cross B? I have to first define A and B. This statement here has no meaning mathematically without these statements already existing. So what I would get in this case is the set of ordered pairs where the first element of the ordered pair comes from A, the second comes from B. So A1, A2, A3, B1, B2, oops, B3. Now, notice that. Now, there's some vocab, and some of this vocab I'm going to introduce, we're going to work with more specifically next day, but there's some stuff going on here. This is an ordered pair. And normally when we think of ordered pairs, we always think of the first element coming from the domain and the second element coming from the range. That's pure algebra. But that's not exactly the terminology we want to use in this case here. The first element comes from, we say, the domain. The second element is from something called the codomain. Now, again, we're going to get into this more in depth over the next couple of days, but range and codomain are not exactly the same thing. Again, those who've had linear algebra and you talk about vector spaces, very, very important that we understand the difference. The range is the amount of the codomain that I actually used. Okay, so when I'm going, if I take a function in baby algebra, you know, y equals f of x, the domain are all of the conceivable inputs I could use, and we'd say the range are all the outputs I would get from that. But back up a step. If I can input any real number in general with functions, I can input any real number and I can output any real number in general, then my domain would be the set of real numbers, my codomain would be the set of real numbers. The range is that specific function, what did I get? So if it were y equals x squared, I'm still inputting real numbers and getting back real numbers in general, but y equal x squared, I only returned non-negative real numbers. So my range would be the non-negatives, even though the codomain is still all real numbers, because my next function might be y equals 2x. Now I can input any real number and I can output any real number. So my codomain and my range would be the same in that case. And there's vocab that goes on here. That's where, remember things like one-to-one and on-to, and yeah, all of these things. This is where those terminologies come from. But this is it. That's all I got to worry about with the Cartesian product. Now, I can do a Cartesian product and I can keep going. So for example, what if I wanted to do, just for fun, because this is all about fun, what if I wanted to do A cross B? That means I'm going to do the Cartesian product of this set and this set. Now, I'm not going to write out the whole thing. It's going to be too long. But my first element is A. My second element is A1, and it'd be that, comma, A2, comma, A3, and so on. So I take A, comma, all 6 of these, then I do B, comma, all 6 of these. So I basically would have an ordered pair within my thing. So here, the entire thing, this entire thing is an element of the Cartesian product. This guy here is an element of this Cartesian product. This character right here is an element of this set. So think of the elements as the things between the commas, if you will. Okay, that's not complicated, but it's notation that you may not have seen before. So you're going to find this is just not that complicated, but you want to go through this as to the best you can. So we've already introduced some vocab today, and I have some fun when it comes to vocab, because a lot of folks, you know, they try to get the math, but they don't pay a lot of attention to the vocab. From 2016 to 2018, I taught the math portion of the GRE test over at San Diego State. The GRE, think of that as like the SATs for grad school. Most of you, I would hope, would consider going to graduate school after you get your bachelor's degree. But most situations you have to take the GRE. Sometimes you just take the general, sometimes you take a subject specific one. So if you were a math major, for example, you take the general and then you take the math specific. If you were physics, you take the physics specific. Computer science, the comp sci. But the general is just English and math, but the math is algebra, statistics, and geometry. So it's not exactly the things you would think it would be. So I taught this for a couple of years. It was a lot of fun. If you were taking this course, it's 4 Saturdays in a row. 2 of the Saturdays are English, 2 of the Saturdays are math, and it's not always the same. Sometimes math might be 1st and 3rd. Next time it might be 2nd and 4th. Next time it might be 3rd and 4th. Next time it might be 1st and 2nd. They'd change it each time. And it was about every other month. So I probably met like 12 times a year, and it would be all day on a Saturday, and usually about 40 to 50 students. And you could take the course as many times as you want. You paid for it once, and you could take it as many times as you want. Just like the GRE, you can take as many times. You don't want to take it many times, but you can. So I would go over these, but the geometry, because I could teach them enough statistics to get through and algebra, but we'd get to the geometry. And one of the days was just geometry. And geometry has so much vocabulary. If I was talking about angles, so what was it? Well, there's supplementary angles, complementary angles, vertical angles, congruent angles, adjacent angles. That's just angles. And if you don't know what all of those words mean, then it would make no sense. So when I would talk to them about vocab, I would tell them a personal experience that I had. Several years ago, partly out of boredom and partly I wanted to move up the pay scale, I went back to school in the early 2000s. I went back to school to San Diego State to do statistics. Okay, so I'd get done with my normal teaching day at Mesa College, and then either in the afternoon or the evening, and every semester I'd take 1 and sometimes 2 classes. And I did this for about 5 years. The last semester I took a sabbatical. I actually became a full-time student for 1 semester. Sabbatical is the greatest thing ever invented. That means I got paid my full salary to go take classes at State to move up on the pay scale at Mesa College. They paid me to move up. That's very cool. So then I finished the master's program for statistics over at State. But I had one particular class Non-parametric statistical methods is the gnarliest class. It's the one that all the stat grads even avoid. And Dr. Liu, the late Dr. Liu, he just passed this last year. He was one of my favorites. I had him for several classes. And one particular day, now you have to understand, most of the people in these classes were either already PhDs or working on it because they came from other fields. And one particular day, he's doing a lecture and he's talking about this specific statistical method. And he kept referring to, we need a parsimonious variable to do the next thing. And he kept saying that, parsimonious. And all I could think of was that creepy little orange fruit that my grandfather used to bring over when we were kids, persimmons, kind of gross. But I'm thinking, I have never heard anybody use the word parsimonious. And by the way, I'm not going to embarrass you, but I would bet any amount of money, none of you have even the slightest idea what that word means. I had no idea what it meant. And he kept talking about it. And I felt like a complete idiot. And everybody sitting around me is doing, oh, yeah, sure. And by the way, we're all guilty of this. When the instructor says something and you have no idea what they're saying, you go, oh, yeah, sure. Rather than raise your hand saying, what does it mean? So I went home and I Googled, you know what parsimonious means? It means stingy. Stingy? Parsimonious means stingy? Yeah, that you didn't see that one coming. I'm thinking, what the heck did that mean? Then I went back to the context. We're talking about this really complicated statistical thing. Stingy. A variable that's stingy means it's not giving up a lot of information. Therefore, I want a variable where I need the least amount of information. Because if I need more information, it's more work. I want a variable that requires the least amount of information about it to be able to perform some things. And all of a sudden, it made perfect sense to me. Oh, okay. I want a stingy variable. I want a variable that's not giving out a lot of stuff so I can do all this. So the next class, it's 2 nights a week. He's talking about something and he's doing this stuff and he says, now what do we need to do? And I said, in this case, we need a parsimonious variable to pull off the following blah, 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 blah. You could hear a pin drop. And I'm not joking. I could hear behind me, he said the word. And the class ended shortly after. Before I could leave, half the class runs up and they stand in front of the door. They're not going to let me. Said, could you please explain to us what that means? I had an entire class of people who were nodding and making me feel like an idiot because I'm the only one that doesn't know what it means. And not one of them had any idea what he'd been saying for a whole week. And I'm like, no, I'm not going to tell you what that means. You go look it up. Here, I'm feeling foolish because I'm the only one smart enough to admit that I have no idea what he's talking about, and I figured it out. When it comes to vocabulary, and we all know this, it doesn't matter how much math you know. If there's one word that you don't know what it means, then you can't answer the question because you don't even know where to start. So if there's any part of a concept where there's unknown vocabulary to you, you cannot continue until you know what that is. And this course, we introduce a lot of new terminology. So at any point in the course, if we're doing something and you don't know what the word means, either ask or find out or look in the textbook because the author defines everything pretty clearly. It's not really that complicated, but there's going to be so much vocab during this course, and it'll be words that you may have heard in other contexts. And you go, oh, I've heard that word, but in this context, what exactly does it mean? I will do my best to keep it clear and to define things. But like I said, if there's even one word you don't know, okay, I said, find the Cartesian product today. Is something an element? Is something contained? Are these two sets equal? Now, when we talk about equal, this is one of those ambiguous terms in a class like this, because the word equal means quantitative, right? Equal is numerical, okay? But when we say are two sets equal, in that case, really what we're saying is, are they equivalent? Are they the same? Are they representing the same thing? Because a set is not a numerical value, and that's where it gets a little bit tricky. Are two sets equal? Are they the same sets? Do they have the same list of elements in them? Okay, so that's an important distinction, because if I said, what's the cardinality of a set? That's a positive integer, or at least a non-negative integer. If I have an empty set, its cardinality is 0. Okay, now what does the word discrete mean in discrete math? This is really, really important that you get this. Okay, all of you in here have had calculus. Calculus is the study of continuous things. But you said, well, we talk about discontinuities in calculus. Yes, and I'm continuous between discontinuities. So if my domain is all real numbers except a handful of things that made a denominator 0, okay, My domains are still infinite. If I said my domain is only the numbers from 1 to 2, but there's an infinite number of values between 1 and 2. Continuous means there's no next number, and there's always an infinite number of values between any two values. Discrete is completely different. Discrete it's neither about finite nor infinite. Okay. If I said, how many children do you have? You could have 0, you could have 1, you could have 2, you could have 3, but there's no value between 0 and 1. See, how many children you have is a discrete count. How much money you have is a discrete count. How fast you ran 100 meters, that's continuous. Because you could report it to an infinite number of decimal places, and between any two times, there's an infinite number of times. So right off the bat, all measurements, I'm talking physics and chemistry too, all measurements are continuous. But when we report a measurement, we report it as a discrete value. Again, keep that in mind. So if you said, I'm rounding it to this number of places, I'm taking a continuous value and I'm rounding it for the purposes of reporting it. Now I'm reporting it as a discrete value, knowing that there's an infinite number of possible values. So again, something like a race could have an infinite number of values. But did you finish first, second, or third? There's no value between first and second, is there? I finished 1.5. No. So discrete mathematics, we do not work on continuous things in general. We work on discrete things, which means that when it comes to the number side of things, we spend a lot more time talking with rational numbers and integers than we do with real numbers. And we really don't work with complex numbers at all. In fact, unless you've had linear and diffie-qs, you probably haven't done much of anything with complex numbers, and that's okay. That will come later on. Now, I'm going to open it up for questions. I don't really think we need to do a separate office hour, so I'm going to go ahead and go back to gallery view. If you have a question, wave at me just for a moment, because I've got two screens here. Anybody got a question? I'm on screen 2. Most of you just have the blank look on your face. You're still waking up. Again, I don't need you to come to lecture, but I think coming to lecture is easier because then you can just ask the question as you have it, if you have it. We're not doing things that are calculation based in general for quite a while. There are a handful of times I will teach you an algorithm to do something, and the algorithm is usually really, really simple. So most of the things we do are not going to be heavily numerical. In other words, no calculator required. Not until much later in the course, probably the last third of the course before we actually do things involving calculations. And that's because we're going to be doing what's called the combinatorics. Combinatorics, again, that if I said, we're rolling the dice, we're flipping the coin, we're doing things like that, finding expected values, anything like that where there's now a calculation, that comes later. So that's the last part of the course. In your syllabus, that would be chapter 9. So before chapter 9, there is very, very little involving numerical calculations. Again, it's concepts and explanations of things, proving something is or proving something isn't, and doing a lot of stuff with language. Okay, I'm going to make a statement and say, now what's the contrapositive of this statement, or what's the negation of this statement? Things of this nature, which you're not going to find terribly complicated. All right. Does anybody have any questions? I'm going to dismiss you. Normally we'll have office hours, so just not a whole lot today, because I'm sure. Francisco, unmute yourself.
Hello. So I think that I normally struggle with the concept, but I do the math right. I think that's how I am. But do you think I'll struggle in this class?
Well, remember, this is not calculation based. So I know what you're saying, because I teach calculus, and many of you have had calculus with me. And in something like calculus, let me give you a simple example. I taught remedial algebra at Mesa for a long time. I teach Math 46. And a lot of people think, well, if I got the right answer, then everything I did was valid. I would teach them manipulation of negatives early on, negative raised to a power kind of thing, -1 times -2. And I would ask a really small, simple product of negative numbers. And students would make multiple errors and sometimes get the right answer. You say, how could that be? Yeah, as long as you make an even number of errors, Think about that logically. I'm doing a short, sweet product of negative numbers, and you're saying it equals this equals, and you made an even number of errors, you're going to get the right answer. But if you made an odd number of errors, you're going to get the wrong answer, because the only thing you had to do was, I've got a bunch of negative ones times each other. Your answer is either going to be 1 or -1. So in other words, it's not the answer. In that case, it's always about the process. Do you understand the process? Because it's purely a calculation. But in this class, since you're not calculating, you're going to be giving an argument. And the nice thing about that is there tends not to be careless errors. So if I say, I'm going to the store today, now give me the negation of that, or give me the contrapositive of that. You're going to say, okay, now I need to rearrange the words, and there's only one way I can do this accurately. You're going to find that it's a lot simpler in many cases, because again, it's logic-based, not calculation-based. So hopefully that helps you. I know people, when it's calculation-based, you go, oh gosh, I might make a mistake. Yeah, you can always make mistakes. But again, very little with calculations. And when we get to the calculation-based stuff, just hitting the right buttons on your calculator is sometimes all you need to do, with things like factorials and stuff, right? There's not a whole lot of places you can go wrong, in other words. So yeah, this is a class, again, if you're in this class, you've already demonstrated that you're better than the masses in mathematics, otherwise you wouldn't be here. And you're going to actually find this class, it's very different from calculus. But a lot of you will actually find this fun. I tell people when they say, what is discrete math? I say, discrete math is fun math for people who like math. Calculus is very difficult for everybody when they do it, but eventually you get really good at it, right? But this is a class where everybody can be good right off the bat. My top student last semester wasn't even a calculus student. He had to petition to take the class. So he hadn't had enough calculus to take the class. So that says a lot right there. In fact, I think 2 of my top students hadn't actually met the calc prerequisite. So I had to do a prerequisite challenge for them to get them in. they were never challenged because again, it's not calculation based, but it is logic based. So that will really help you if that kind of stuff comes more naturally to you. Okay, anybody else? Yeah, wave at me if you have a question. I'm going from screen to screen here.
Professor?
Hold on, wave at me. Who's asking? Omar, yes.
So I noticed on the syllabus that we don't have homework. It's just basically quizzes and exams. Is that?
Well, the homework, and I say this in every class, I'm expecting that every single student can do every single problem in every single section, unless I say we're not doing that section. Now, when it comes down to it, do you need to do every single problem to get good at something? Well, if there's 20 similar problems, which there aren't in this case, by the way, but if there were 20 and you could do 4 or 5 of them perfectly, great. So I said in the homework, I would start off with the bold-faced ones because those all have detailed solutions. That's where I would make sure I can do every one of the ones that are bold-faced. Now, obviously, you want to know that you can do everything. But if you got 10 problems in a row, they're all similar in nature, and you've gotten a couple of them right, you're probably good. Because right now it's fairly simple. But as we go further on and we get into some of the proofs, each problem is different enough that you're going to want to do more to feel like you've got a good picture of it. Because then when you ask questions, your question will be, well, in section 4.3, I got to this point on problem 17, and I don't know where to go from there. That's a good question. But if you're saying, well, I'm just going to do the quizzes and things like that, well, it's kind of dangerous because where I'm expecting you to become proficient at a concept, and if you're only doing one problem, right? You're saying, I'm taking a chance. Think calculus for a moment. You're learning derivatives. You've got to practice literally hundreds of derivatives to get good at it. But I'm going to do one. I'm going to do it really well. I don't think I'm going to understand derivatives because there's so many versions, right? I got to do derivatives until I can do any derivative. Now, having said that, I have calc students who will try to do calculus without doing any practice whatsoever. That's, that'd be like trying to do algebra without doing any practice. In this class, you don't have to do tons of practice because, again, it's conceptual. But you want to know when you are, and I'll use proof as an example because we're going to do a lot of that. It sounds scary, but it's low-level proofs. You want to know that you can give a successful argument. That's really what you're doing. You're arguing a point, and the reader should be able to say, yep, you convinced me. Think of it like that. Now, can you do that just doing one problem? I tend to think no. I tend to think you got to do a little bit more practice. So the reason I don't assign specific problems is because no math teacher you have ever had at the college level has ever actually looked at your homework, by the way. I got a rude awakening for you. There's no possibility. If you did the minimal amount of homework that everybody wanted, I had an algebra class one time calculate how many hours it would take me to grade it, and they came up with somewhere around 200 hours a day I would spend grading homework if every student actually did all the homework I'm telling them they need to do. Nobody ever looks. No, you might have an instructor, you turn in 10,000 problems and they randomly pick 3 or 4. Yeah, no. The quizzes are my way of saying, okay, you did all of these problems. Let me just take some generic things that I expected you to be able to do. And if you could do those problems in general, then every quiz, I don't want to say easy. I want to avoid using the word easy, but there's never going to be a quiz that you can't power through. You're supposed to get A's on all the quizzes. You're supposed to, because you can. You got a week. This first quiz, it can't take you 10 minutes, and you have a week. But if you just sat down and did the quiz without doing any of the problems in the text, you might miss some of the questions because you're not really sure how to attack them. I ask you like a Cartesian product in there. I think you want to do a few Cartesian products just to make sure you got it. Things like that. So I'll never know how much work you do, but it's evidenced when people are not doing well on short and what really should be relatively simple take-home quizzes. If those are not going well, it usually is an indication there's not enough practice. Flip side is, so other folks will say, well, I'm doing every single problem every single day. Yeah, that can get kind of time consuming. So it's up to you to kind of figure out. This is an upper level class. Results in a class like this tend to be very high. Okay. Now, people always ask, well, do you grade on a curve? Oh, God, no. If you ask the question, then you don't know what it means. If you've had statistics, you know what it means. Grading a curve means you are, the person next to you has just as much input on your final grade as you do. In other words, you have to be ranked. And then there must be a cutoff. Well, considering last semester I had 6 students in the course, because, by the way, I throw bonus questions periodically on a quiz, extra credit. And I throw a bonus question on every exam. I had 6 students last semester that ended the course with over 103%. 6. If I curved the grades, that means that 4 of those students wouldn't have even gotten an A because the class average was so absurd. That would have meant under 90 would be an F. A curve means you're penalized in a class like this. If you've been in Calc 3 or above, most of my Calc 3 classes, the final semester average is around 90%. Same thing in linear, same thing in differential equations, same thing in this. A curve makes the 90 a C. That's what a curve means. Yeah, you never want to be in a scenario where somebody graded on a curve. You've never been graded on a curve in your life. I can absolutely guarantee you that. When someone says, I'm going to curve the scores, no, they're not doing that. They're scaling the scores. They're given an arbitrary multiplier because the scores were so bad, they didn't want everyone to feel terrible. But if they were curved, your ranking would determine your grade. If you're in the middle of the cluster, you're a C. You can't get an A unless you separate yourself by enough standard deviations above the mean. And in a high level class, by the way, there would never be an A if I graded on a curve because there's not enough separation at the top end because everybody's at the top end. So in a class like this, can everybody get an A? Yeah. In a curve, can everyone get an A? No more than 10% of people can get an A in a curve. Yeah, so no, I would never grade on a curve because then that penalizes you for being good because everyone around you is pretty good too. So yeah, so understand that excellence is rewarded in that whatever you do, if it's excellent work, you're going to be rewarded, you're going to get your grade. Your grade is not going to be determined because somebody else also, okay? That's very, very important that you understand that somebody else's grade is not going to determine your grade in any way. Only your performance will. And again, in a class like this, you guys are, again, the top of the food chain. You guys are the people probably getting your associate's degrees this semester, probably moving on to university in the fall and all that stuff. As the course goes on, we will talk about things like that too, transferring and stuff like that. And people will always ask, well, what should I take next and things. I will try to give you guidance when I can. All right. If there are no other questions, then make sure you're checking Canvas. I will often post some of the quizzes ahead of time. I don't want you to work things too soon. Wait till at least you've seen the material. Otherwise, you may be trying to figure it out on your own and you may have misconstrued something. You can always turn in quizzes early. I do not need you to wait until 7:58 next Monday to turn in the first quiz. Most people will turn it in early. And if you turn it in really early, sometimes I can give you feedback on that quiz. Okay. Is somebody raising their hand here?
Yeah, yes, I am.
Who's, I don't see a
Joe.
Where are you? Do you have a face?
I do. I have a face. Yes.
Okay. What's the question? Oh, there you are, Joe. You guys, this is the ultimate between Brady Bunch and Hollywood Squares. It's everybody. Okay. What's happening?
I just have another question about quizzes. I think you said it already, but we study exclusively with the book and the lectures. Is that correct?
As opposed to what? You mean?
No, I was just making sure. So
Oh, okay.
are the questions from the quizzes adapted from the book?
Pretty much, yeah. When you're practicing the problems in the textbook, the author does a good job of really giving you a broad range of things. And then when I'm asking you stuff, it's just sort of plunked right from the middle, fairly generic. So, and I will throw bonus questions periodically. And the bonus question is extra challenge. And there's no negative for not being able to do it, but I always think it's silly to not do a bonus question, So in terms of the textbook, again, I do not need anybody to buy a textbook if that's uncomfortable. And if you are comfortable sitting at your computer reading a textbook, again, I go crazy. I'm at my computer way too much as it is. I do not, this is so terrible. I have 3 sets of glasses. I actually have a set of computer glasses. That's how bad it is. I have a set of glasses that are just for the computer screen, 30 inches away, because I can't see the computer anymore with my regular reading glasses. For me to sit in front of my computer for several more hours to read a textbook would make me crazier than I already am. But if you don't mind, then you got a free PDF online. You see, when I'm doing anything involving a textbook, I get as far away from my computer as I can. I sit outside, I have a patio outside and a fireplace, and I just kick back, after I'm done with my Sudoku, and I'll go through and read a book. I don't want to read a computer screen. But again, free is still free. And the 4th edition was considered the best ever, And the 5th edition is, I was going through it, I think it's like 2% different, so it's not necessarily an improvement. It's just what's available. If you did, by the way, I'm curious, did anybody has anybody got a physical hard copy of a book, either the 4th or the 5th? Jess, you do? Which one do you have?
I think it's the 4th edition. It's still in the mail though.
Oh, okay. I was gonna say, where did you acquire it from?
Amazon. I got it like used.
And how much did you pay, if you don't mind? Because that's important.
I think it was like $50.
Oh, that's not bad. Brand new, it was about 300. And if it's in good condition, if it's me, I'm going your route. I don't say it jokingly. I can't stand sitting in front of my computer. I have to spend 1 to 2 hours a day just answering emails. Plus, I spend a few hours a day writing on my computer. So, and then I'm zooming. Now, a couple of minor things. When you email me, okay, a lot of times you'll see my response might be, 6:45 in the morning. I'm up at 6. My wife has to get up at 6, and I get her out the door, and because she teaches up in Escondido. So I'm up, I've had my coffee, I've done everything. So I do answer emails sometimes in the morning, but there will be a point in the evening where I don't answer emails anymore. I try to walk away from my computer. 10 o'clock is almost too late. And it has to do with the whole vision thing. Some of you know me, I don't sleep. It's not a choice. I have a difficult time. I think they call it a disorder. I don't sleep very long, and I don't sleep very much at night. But staring at a computer screen is the absolute worst thing you can possibly do if you want to go to bed. The whole blue light thing, it really messes with your brain and everything else. So I try to walk away from my computer before 10 o'clock if humanly possible. And a lot of you will email me. I got a whole bunch of emails that came in after midnight from you guys. No, I'm not responding to those until the next day. So if you have an important question, don't wait until 10:30, 11, 12 o'clock at night. I'm not going to see it that night. I'm going to see it the next morning. Okay. If you email me during the day, I'm very likely to get back to you within the hour. In fact, if I'm on the computer when you email me, I'm likely to get back to you immediately because I can see it show up on the screen. So in terms of communication, I will always respond to your emails, but I won't respond to the late night ones because I'm off my computer. I'm not going to bed yet. I'm just walking away from the computer, preferably closer to 9. Sometimes I might not be till 10. Okay. Everybody got that? So I want to make sure you understand I'm not avoiding you. Well, I might be. Probably not avoiding you late at night. It's just I'm not in front of a computer screen anymore. Okay. Anybody else? I'm toggling back and forth between the two screens. Okay. Good day to get rid of all the logistical questions. I don't want a week from today you to be uncertain. Again, when it comes to the quiz, you can send it to me at any time, but I don't need them until right before Monday's class. And the thing is, because you're just simply emailing it to me, there is no logic whatsoever to be late. Now, from an attendance standpoint, it's going to happen to every student in this course. Life got in the way for quiz, fill in the blank, quiz, whatever number. Life got in the way, didn't actually get around to that one for whatever reason. Then just simply email me a blank quiz. Attendance in this class is on your production, what you turned in. Because Zoom lectures are not required, in fact, I've already taught more than one class asynchronous on Zoom, so there was no attendance whatsoever. Attendance is strictly, did you turn in whatever was due? There will be something due starting on Monday. There will be something due every day through till the final exam. Not turning something in is being absent. And since it's so easy to turn in something, even if it is just a blank, okay, it's the only way I know that somebody is still engaged. If I go a week or more and I haven't received anything from you, I'm not expecting that you're ever going to come back. But most students do not drop themselves. Most students just stop attending. And the problem with that is, if you stop attending and you get a W is a ding. But if you stop attending after the second drop deadline, then you actually get an F in a course that you didn't even intend on finishing. And I don't want anybody to ever get an F or a W in a course that they weren't going to finish. Okay, there's no positive there. I had a student last semester. He only came to the first few classes, and then I dropped him, and he demanded reinstatement because he wanted his F. It was because he was on financial aid. The knucklehead doesn't realize that when I turn in the grades at the end of the semester, financial aid students, I have to put their last grade of attendance, which went all the way back to the beginning of the course, and he has to pay back. That's the one thing. If you're on financial aid and you either drop the units or you drop the GPA, you got to pay it all back. A lot of folks don't realize that. You signed a contract. People tend to avoid that. If you're on financial aid, you signed a contract that says you will maintain a certain GPA and a minimum number of units. Now, a 3-unit class is going to be a lot less damaging than a 5-unit class if things go astray, okay? But do be aware that if you're only taking a few classes, can you absorb a bad grade? I don't want anybody to get a bad grade, but can you absorb one? And it's the whole financial aid issue and all that stuff. Those are things that people have to deal with. That's the primary reason people don't drop. It's a money thing. They're saying, well, if I drop, then I lose my financial aid. Well, if you drop below GPA wise, you got to pay it back. And the worst part is if you go on academic probation, GPA academic probation, you not only got to pay it back, you got to wait a year to reapply. The damage is pretty severe if people aren't paying attention to the details. So everybody here if you're here, you're probably in the right place, and hopefully that, this semester's, I don't want to say easy, but hopefully it's successful. All right. Anyway, folks, have a great rest of the day. I look forward to seeing y'all Wednesday morning. Yeah.